Nick said, my name is Kasia. My last name is Rachuta, which is a little bit harder to pronounce. I'm going today to talk to you about first steps to transition from SQL to Pandas. So a bit of my bio. I graduated with a master's in theoretical physics 3 years ago. I went to University College London. Then I moved to San Francisco shortly after, and I currently work as a data scientist at Medium. I'm a PyLadies organizer for the San Francisco chapter, and I recently completed a Delta Analytics Fellowship, and I'm also interested in Delta for Good. So if that's something that interests you, come and talk to me afterwards. So, Python alternatives for queries. There are many ways that we can combine the Python and SQL querying way of looking at data, and one of them is hooking up Redshift or any other database. I've mainly dealt with Redshift myself into Python, so that way you write a script and you can actually query your database in Python writing SQL. There's also a SQL module in Python, and you can also use Jupyter Magic in IPython or Jupyter Notebooks. Jupyter Notebooks are a very common IDE for data science, and that's what I will be using throughout this presentation. I personally haven't had much luck with either the SQL module or the Jupyter Magic. It felt kind of junky. Couldn't really get it to work very well. So I wouldn't recommend those options, but if you're interested, go check them out. And finally, there is Pandas. So Pandas is one of the most common data science libraries in Python. Some of its advantages include that you don't really need a SQL database. It's very easy to use with any type of file you may want. So you can use a JSON file, a CSV file, an Excel file. You can use pickled files, and so on and so forth. It also has a nice data visualization integration with other Python libraries like Matplotlib or Seaborn. And finally, it's incredibly well documented. There is tons and tons of documentations on it. There are a lot of really good examples there. It's a very common library, so even if something that you're looking for is not documented, someone probably has asked that on Stack Overflow. So, starting off with a data frame. So it's a Pandas equivalent of a table. Firstly, I'm going to import two modules. The first one is Pandas. I import it as PD, that's the convention. And the second one is NumPy as NP. So NumPy is another popular data science module. I won't use it extensively here. I will mainly focus on Pandas, but there is one use case of NumPy that I want to show you. And finally, I'm importing a CSV file. It's trained.csv, that's what the file is named. Throughout the stock, I will use 3 different data files. 2 of them come from the Kaggle Titanic dataset. So it's a dataset that often used for learning logistic regression on Kaggle. And the second one is more millennial, so it's a dataset with avocado prices. So I'm very briefly going to go over a data frame inspection before I dive into some translations from SQL into Pandas. The first one is dataframe.shape. That tells us the number of rows and columns in our data frame. And then the second one is dataframe.columns, which tells us the different number of columns we have in the data set. So here we can see that we have a passenger ID, whether they survived, what passenger class they are, their name. So as I mentioned, this comes from a Titanic data set, and it's used to learn to predict whether someone has survived Titanic. Another type of inspection that I do is dataframe.dtype, so it tells us different data types that we have in the data frame. So sometimes I want to know whether something is an integer or float. That may have some problems that the ones I most commonly run into. Sometimes something is saved as an object where you really want to have that as an integer, and so on and so forth. So it's always useful to inspect that at the beginning. Another thing is duplicates, so I'm not going to go into a lot of details about it. I will give you my GitHub handle at the end. There is a file there called blog where I show how to deal with both duplicates and missing values with some examples. Here, the first one, dataframe.duplicated, is going to output a Boolean value for every column and every row, telling us whether this value is duplicated. The second one, dataframe.dropDuplicates, will just drop any row that has at least one duplicate in it. And then I do the same thing on particular column. So data frame, and then when I wrap it in a column, will tell us about this particular column. It's not going to run that function on the entire data frame. And same with data frame column drop duplicates. And null values, so here you can see that when I do dataframe.isNull, we will see a Boolean value of whether an entry in a row is null. So for most of them, they're not nulls. We can see that for the first entry on cabin, we have a null value. And then drop NA drops any sort of row that has at least a null value. As any data scientist would know, that's a very dangerous way of dealing with data. If you look at the indices on the left-hand side, you can see that we're now left with 1, 3, 6, 10, 11, and then 21, which means that we have dropped a lot of data. So that's probably not the best way of dealing with it, but it's one way. So now, moving on to SQL into Pandas. First one I'm going to start with is select star from table. So as I mentioned, I use Jupyter here, meaning that you don't actually need to write print statements. So first, I just say data frame, and it will just print the entire data frame, which is an equivalent to print data frame. Throughout this talk, I will never use a print statement, so I just wanted to let you know that this is equivalent. And here we can see our entire data frame. Obviously, I took a screenshot of the first few rows, so I'm not displaying the entire thing. But in the Jupyter notebook I will share later on GitHub, you can see that we will be displaying all of the rows. Now, looking at limit. So limit means that we just put .head and then the number of rows we want to limit on at the end of the function. So here I picked 7, and then here we can see that I just put a more generic function with n at the end. So here we can see the 7 rows. The default is 5. So if you just do dataframe.head and put curly brackets on it, you will just see 5 rows. One thing that I didn't mention is that for most of these operations, I'm actually not saving the new data frames or any new objects that are produced. So just to inform you that this is how you would do it. So I would save new data frame equals dataframe.head 7, meaning that I just saved a new data frame, which is equivalent to the old data frame's first 7 rows. Now, select distinct embarked is just a column I picked at random from table. So we just ran .unique curly brackets on that column name, and we can see that there are 4 outputs there, SCQ, which I don't really know what they mean, and then there are null values, which also show up here. And then looking at an individual column, you can do select name from table equivalent, which is data frame double squared brackets name. Why is it important to do double square brackets? Well, so in Pandas, we actually have 2 data types. One of them is series, and one of them is a data frame. Series is just 1 column, and data frame is an array of series, and so multiple series, which is more of an equivalent of a table. So if we just do single squared brackets here, we'll output a series instead of a data frame. Now, moving on to word clause. So an example here that I'm looking at is passenger class being the 3rd class. So here is the syntax at the top. We need to say data frame, put it in square brackets, say data frame again, use the column name that we want to do the word clause on, and then put a double equal sign to say 3. And underneath we can see that all of the outputs I'm getting are from the 3rd class. There are obviously more rows. I just took a screenshot of the first few.
Why do you have data frame repeated twice there?
Because otherwise it doesn't run.
Okay.
Yeah.
So what the data frame p class equals 3 is making a Boolean mask of true or false for each one in that thing that's equal to 3. And then the second one is saying, okay, only take the rows where that's true. Okay.
Thank you. Okay, and then I do an end clause, and in a minute I will show you an or. So we can do the same thing, but now we have to put both conditions in curly brackets, the first one being 3rd class. Then we just put an end sign, and then I put the sex as male. And here, again, I inspect and check that this has run correctly. And then this is the equivalent of our OR statement, so it's just a line that we need to put through the conditions. We can add multiple conditions to that. I just put an example of 2 of them. And here we can see that all of the entries either have passenger class 3 or a male under sex. So we have 1 passenger from first class, but it's okay because their sex is still male. We also have 1 female, well, 2 females, both of them are from third class. Now, sorting values. So we do DataFrame.sort values. Then we say which column we want to sort it through, and then I pass an argument of ascending equals false. The default is that the data will be ascending. So if you don't want that, then you need to pass that argument. Otherwise, you don't need to specify ascending equals true. And here we can see that this has indeed worked. Now moving on to doing some aggregate functions. So when I look at count, there are actually many different ways to do it. The first one is this one. So instead of grouping at the end like we do in SQL, we actually have to group at first. So we need to say data frame, then group by on which column or columns. We can group by on multiple columns, and then we do count. So you will see that it's counted all of the different entries in the different columns, and you can also see that those numbers don't match up. It's because count doesn't include null values. So from this we can infer that, for example, the embark column has 2 null entries in the first class. The other one that's a much easier way of looking at this is grouping by passenger class, as I did, and just passing size on it. So that will tell you whether it's how many entries are in each class, and it does include all the other columns. And another way of doing it is you pick 2 columns that you want to look at. For example, passenger class, and the second one I looked at is passenger ID because there are no null values on it. And I just take both of these columns from the data frame, then I group by on one of them, and then I do count. So that way I don't include all of the rows. Now, doing multiple aggregates. This is when I start to use NumPy. So I group by. Here I want to look at each sex, what's the average age for it, and count the number of people in it. Here first I group by sex, and then I put something called agg, which shows it that I will be doing multiple aggregates. And within that I specify that for age I want to use NumPy function mean, which will find the average, and for sex I want to use NumPy function size, which will give me count, like I've shown before. It typically excludes those values. Now, I'm going to show you how to do joins and unions. So I'm using 2 data frames here. Now I'm going to join it with the test data set. So I was using the train data set. Now I'm going to use the test data set, which obviously isn't how you would deal with it in real life, but for the sake of example, that's here. So I use something called merge. So I need to tell it that I'm using Pandas merge, and then I show which is my initial data frame and which data frame I'm joining. Then I tell it what column I'm joining it on. I can join on multiple columns. It doesn't need to be just one. And in this example, I'm doing a left join. We can do right joins, outer joins, any sort of join we like. The default is an inner join, so that's the one that we don't actually need to specify. Here you will see the output, so you can see that it starts to add suffixes, x's or y's in case the columns are repeated in both data frames. So the initial one is an x and the one I'm joining on is a y. But we can actually specify which suffix we want to use for each of them. So now I started to add those suffixes, and I said that the first one I want to be underscore data frame, and the second one I want to be an underscore test. That way I will know which data frame each column comes from. So we can see that I didn't manage to capture all of the rows, but if you look at the Jupyter notebook later, you can see that all of them that are repeated through both columns are included there. Another thing that is done quite frequently is union all or union. The way it's done is you first do frames and then I specify which two I want to do. We can actually specify as many data frames there as we'd like to, and then we do Pandas concat and then pass frames in it. We can also just do it straight away. I typically do it this way just because it's a little bit cleaner. The reason why it's union all, not union, is because for union we actually need to do this and then drop duplicates. So as I've shown you at the beginning, you have to do this and then you have to pass the drop duplicates argument on this. And here you can see that those started to get concatenated. So now I'm going to move on to avocado prices. So I am importing another file. It's called avocado.csv, and now I just renamed this as avocado.df. I've imported that, and then here you can see the first 5 rows of the data frame. So you can see that we have dates that are weekly, we get average prices, volumes, the number of total bags, small bags, large bags, extra large bags, types, years, regions. I won't be using all of those columns, but I just wanted to show you what data frame I'm working with. And here I'm going to show some window functions. So some of the most common window functions that I deal with in my job are, for example, rolling averages. So because those data frames, you can see that the date was actually in the weekly gaps, the data wasn't daily. I'm not going to do a 7-day rolling average. I'm going to do a 4-week average to kind of mimic month. So in SQL, that would be average on average price, and then over order by date rows between 3 preceding and current row. That obviously assumes that all of your dates are in the right order, which is something that you obviously should always check beforehand. And it's actually very easy to do in Pandas, which is avocado.df, and then I pass the average price column because that's the one I care about. Then I add rolling 4. So that means that I'm looking at the rolling 4 weeks, and then I put mean at the end. And running this will output this. So we get the first 3 rows with null values because we're looking at 4-week rolling averages, and then we start to get the output there. Obviously, that's just outputting that one column. If we wanted to append it to the data frame, we would need to use data frame column name equals this function that I specified here. So similar to what I've shown right at the beginning. And then the second one is a cumulative sum. Another thing that I use very frequently, which in SQL will be sum over average price. Then we order by date, rows unbounded preceding. And doing that in Pandas, again, is absolutely dead easy. I use avocado.df. I look at the average price column, and then I pass some function on it, which is just cumulative sum for intuitive. And here we can see that those numbers start to increase as we go down the road, which means that this is probably doing the cumulative sum as we expected.
Is that command mean that the data set data frame is always sorted by date, or you have to specify that beforehand?
So usually I would specify that beforehand, unless you know your data very well or you're sure that it's sorted. In this case, I checked beforehand actually that it was in the right order, so I could run those functions. But yeah, it's always safe to look at that. Yeah, that's it. So thank you for listening to my talk. I'd love to take some questions.
We have plenty of time for questions.
Thank you for sharing. Are there particular SQL expressions you find difficult to translate into Pandas?
I don't think there are any particular expressions I found hard, but I think that overall, Pandas and Python have a steeper learning curve than SQL. SQL is a lot more intuitive, so I found that was a lot easier to pick up on. And at the beginning, it really threw me that you need to group by on things first, and then actually when you group by on something and you don't run an aggregate function on it, it's not going to output anything, so you always need to specify that.
Do you have any best practices that you recommend for dealing with setting with copy warnings?
Can you give me more of a specific example that you deal with?
Yeah, like every time you do these set operations and you re-index them, you're getting copies. And if you try to reselect another data frame, like say with an index that came out of a copy, causes a lot of like problems. And typically, for me, best practices might be copying the data frame when you're doing a reassignment to your variable, data frame variable. So I'm curious if you have best practices on that.
So I actually don't really run into that warning very much, partly because my way of doing things is that I import the data frame, then I save a copy, and then I work up that copy, and then every time I do something, I actually save that as a new data frame. It's not a great practice if you're dealing with absolutely huge files, but usually when you're dealing with slightly smaller data, it's a good way that you can actually go back to your previous version, your previous data frame, and then look at it, especially if you are just testing a bunch of things out and a bunch of calculations. Don't know if that helps.
Can you mention some of the advantages of using Pandas over SQL?
So Pandas over SQL, or do you want to advantages of like
Specifically in these queries, are there any advantages of using Pandas?
Well, so Pandas, I use Pandas on top of Jupyter. It's very easy to install and start using. When someone gives you a CSV file and you try to do SQL on it, you need to like install a whole database and like input that, which I found a lot more complicated. So it's a lot easier to get started with. It's a lot easier to deal with like different file formats. You have all that documentation that I mentioned earlier. So if you get stuck on anything, there are probably some very good examples of that somewhere. And as I said, it's very commonly used. So in the data science world, if you get stuck, someone can probably help you.
Do you see a performance difference in using Pandas versus SQL when you're connecting directly to a relational data model?
Not really. Yeah, I haven't found any sort of performance issues or differences. Although, that's a good question. I think the only time when I run into a problem, it turns out to be actually a problem with like the Redshift cluster. Rather than Python versus SQL difference.
My question is your ultimate intent. I'd considered writing a library that helped people learn SQL that are coming into the Python ecosystem, don't know SQL. Is the intent to write methods that help to do these conversions as a translator?
I'm not sure I understand your question.
My question is, do you want to turn this into a translator for people who understand Pandas or understand SQL and want to move in the other direction? Or just as a learning tool of comparing languages?
So my aim here was to talk to people who already know SQL and are trying to transition into Python or Pandas more specifically, just because typically when you start out in data science, your SQL is a lot stronger than your Pandas, and a lot of time when you're on the job and you're trying to do something in Python, the learning curve is a lot steeper and takes a longer time to learn Python or Pandas, and SQL is just a lot more intuitive.
My question is I'm currently learning data science online, and I'm learning SQL, which is kind of tough for me. How often do you use SQL in your practice as a data scientist in real life? How often do you use it? How important is it, basically?
Every day. And I would say SQL is probably more important than Python, although it depends what sort of work you look for as a data scientist, whether you are more looking into writing production code, whether you're trying to do more of kind of analytical work. If you're struggling with SQL, then there is one resource I would recommend. It's called SQL Zoo. It's it's one of the very few interactive resources out there online. So it actually lets you write some SQL and will check it for you, which is a lot easier to learn. I feel like SQL is harder to learn when you have no data to deal with. Python is in that sense easier because you can just import any sort of CSV file or data frame that you find on Kaggle, or I don't know, a lot of cities have open data sets and you can deal with them that way. With the SQL, it's a little bit harder, so that's why.
Hi. In SQL databases, if a query is running slow, you could create an index on a certain column. Is that possible in Pandas, to do that in order to improve performance on something that might otherwise take hours to run?
That's a good question. I actually don't know because I've never run into that problem. The only problem I've ever had, and there was actually a very good PyCon talk from last year on it online, is using NumPy instead of Pandas because that's more performant. And also to piggyback on that, I actually typically avoid putting very, very big data frames straight into Python. My best practice is to actually deal with it in SQL first and then transition to Python to do machine learning models, for example, or calculations that I can't use SQL for.
All right, if there are no more questions, let's thank our speaker one last time.